power, spell, and magic stuff. Okay, Magician, maximum total damage with spell casting. Magician has various spells. You're given an array power where each element represents the damage of a spell. Multiple spells can have the same damage value. Okay. It is known that if a magician decides to cast a spell with the damage of power I, they cannot cast any spell with damage of power I minus 2, power of I minus 1, power of I plus 1, or power of I plus 2. Okay, so they can't cast any spells that are within 2 spell power of it, but can cast something with equal spell power. Each spell can only be cast once, return the maximum possible total damage. So here they cast 1 and 4. No, they cast 1, 1, and 4. Can cast 3 if they cast 1. Here they can cast 6, 6, and 1. Okay, this seems simple enough, or easy enough to understand. How to approach this? Huh. How to approach this? I think it's probably okay for me to sort. I think sorting is probably the first thing that comes to mind. So if you sort, what do I want? I kind of want to be able to have an array of unique spell powers rather than having duplicated spell powers, just because then the indexing is better. So how to do that? I think I can do like unique power is the set of power, and then make that into a list, and then use unique power to sort. And I want to have a counter or the frequency for each spell power. And let's go ahead and just verify that this is correct. Should be plural. 1, 3, 4, 1, 6, 7. Okay. So what to do here? I think what I want is, well, let's see, what is the range of power? 10 to the 9th. I was thinking maybe having a fixed array of all the powers. That doesn't work. Okay. I have a best array, and this is the best that you can get up to a certain index. So So say n is the range, is the length of the number of unique powers. For every index in range n. So say best total damage up to index I, up to the index in unique power. Like, yeah, so like 0 means that up to the first spell power 1, there's a best total of getting 0, and you could include 1, or you maybe could not include 1. How would this work? Okay, so let's take an example. 1, 2, 3, 4, 5. So what would best mean? So if I use this, if I cast this spell, then I would get 1 total damage and skip these 2 and get 1 total damage there. So it'd be something like that. Yeah. I think the first thing I probably need to do is push down the best value. So let's say the current best is best at this index. I need to push down the current best. So I guess this should mean, should this be n plus 1? Should be 0 times n. If I think I need some n plus 1. So the current best is 0, and if this was a bigger number, then it needs to set the next number up to be possibly that. So if current best is bigger than best at index plus 1, best at index plus 1 is equal to the current best. Okay. Now the other thing is current best doesn't include the current spell. Casts spells with current power. So current best plus equals the current power, which is power at this index, times counts for this power, times the number of spells that have this power. So it'd be 1, and then you do 1 plus the 0, and then you put that into whatever is the next index. where the spell power is at least is more than 2 bigger. Find earliest spell power where this spell that can be cast after this power. For example, if current power is 5, next power needs to be 8, at least 8. Okay, so I guess I can do like while power index is I guess I want a current power as well. In which case we probably want to call this current power. Wow, current power times counts at current power. So while power index is less than or equal to current power plus 2, index plus equals 1. Index is going to reset to, it's not like Java where index is going to be dirtied by this instruction. It's going to reset to the correct index each time it does the update. But now it's just going down the line so that I find the index within, I guess it should be unique power. Unique power at this index is less than or to, so if current power is 5, 7 is less than or equal to 7, so it needs to be bigger than 7, which is 8. Okay, and then at that index I can do best at this index is equal to whatever might currently be there. And whatever the current best might be. And then I think I just return the last value in best. I think I also need to have unique power be, I need to have a backend to unique power in order to prevent it from going out of bounds here. So I think I want to have unique power append and infinite. Feels like this might be right. This is probably some out of bounds error though. Yep. Okay, yeah. You append it after this. Oh, baby. Very nice. Well, I mean, this is okay-ish, but the fact that that went through on the first compilation. Okay. I guess the question is, how or what am I thinking about optimizing here? I think if there are duplicates, then I should probably do the sorting of the non-duplicate set. So unique power is a list of this. Actually, I already did do the sorting of the non-duplicate set. Counts of power. Some solutions want 8 milliseconds, whereas mine want 428. That's ridiculous. Like what? Like, that's not even linear. Like, this is n log n. Is there a way to do this non-linearly? Non-linearly? Or like linearly? One pass? Like, you don't know that it's... How many elements are here? 10 to the 5th. So, I mean, can you do it in one pass? I don't know. I don't think so. Okay, let me think. Best is 0 times n plus 1. I guess this is a little slower here. Emitter index. I guess maybe you can do something that is if the current best is bigger than best at index. Best at this index is equal to the current best. I don't know how much, I mean, that kind of does. No, I don't know how much that helps. Current best is best at index. Current power is unique power at this index. If this is better, then improve it. Find the earliest spell. Gosh. Seems pretty darn fast. Unique power list set power. And that's the number of unique powers. Append. This appending gives you an infinite, so you don't have to worry about going out of bounds here because this will always be false at the when the index is at the very end of the unique list. do something where we don't do this and use a set, maybe? No, a set's just going to do the same. Do. Okay, I think this is optimized enough. I mean, not perfect, but it's okay. So the summary for this is first convert power into a unique list rather than have so basically get rid of duplicates and sort. Keep as separate lists. Make a counter from the original power list to keep track of frequency of each damage or each power value. Iterate over, create an answer array. Equal in size to the unique list, where the ith value in that array is equal to the best total damage up to that index in the unique power, assuming you and the power at that index can be casted. So, i.e., if its power is x, then x minus 1 and x minus 2 spell power were not casted. Iterate over the answer array index, calculating the total power if the power at that index is casted, which means you increment by power times the frequency of that power. So if the current power is 6, current total best up to this power level is, I don't know, 5, and there's 2 spells that have power 6, then you'd cast those 2 spells, add that to the total power of 5, get a new total power of 27. Or not 27, 12. No, what's it? 12 plus 5, 17. Calculating total power and updating the appropriate index later on in answer array with that value. And then finally return the last value in the answer array. There's some minor details that I didn't go over, but basically that's the main gist of it. This is that loop where I'm updating answer arrays, this best array. You get the current best up to this index, get the current power at this index, or the unique power at this index. Yeah, this is basically push current best to kind of down one spot, basically not casting current spell power. So it might be that the best thing that you do is not actually cast at this current spell power, and if that's the case, then whatever the current best is, it might improve whatever would be already there up to that index in the best array. Otherwise, look to cast the current spell power, which is going to increment the total power by that spell power times how many spells have that spell power. And then see the earliest index where you have a spell power after this that can be casted. So if like the current spell power again is 5, then where's the location of this unique spell power 8 or higher, or the earliest index of that. So unique power at this index is less than or equal to current power plus 2. Kind of go down the list and then update that spot on the current best. And then you have just a minor detail, including infinity and your unique power in order to not go out of bounds with the indexing here when you kind of go index plus equals 1. Alright, time complexity O of n log n in order to sort the unique spell powers. The actual process to determine the best array and final best value, final total best value is O of n. It's actually faster than the sorting part. The sorting part makes it long. Base complexity, this can be O of n to maintain the best value array.